This is our lesson on using equal values to solve a system of equations. So if we're given the equations y equals x plus 4 and y equals 3x minus 14, notice they're both equal to y. If they're both equal to the same thing, they must be equal to each other. Think about it if you were weighing something. If you had two different objects that both weighed 10 pounds, those two objects must be equal to each other in weight. So instead of writing y equals x plus 4 and y equals 3x minus 14, we can write x plus 4 equals 3x minus 14. And now this is just a matter of solving a one variable equation. We can subtract x and we get 2x, so 4 equals 2x minus 14. Add 14 to both sides, we get 18 equals 2x, and then divide both sides by 2, and we get x equals 9. The difference here, though, we need to plug that 9 back in because we need to find the y value. When we're solving a system of equations, we're looking for the point where they intersect. That's going to have an x-coordinate and a y-coordinate. We already found our x-coordinate to be 9. We plug it back in, we can use either one of our original equations. If we plug it back into the top equation, we get y equals 9 plus 4. 9 plus 4 is 13. So our point of intersection is 9, 13. Here's another example, y equals 2x plus 2 and y equals 2/5 x plus 10. Again, they're both equal to y, so we can set them equal to each other. 2x plus 2 equals 2/5 x plus 10. I don't like working with fractions or decimals, so to get rid of the 5 in the denominator, to undo dividing by 5, I'm going to multiply my whole equation by 5. So 5 times 2x is 10x, 5 times 2 is 10. When we multiply by 5 and divide by 5, they cancel each other out, and we're left with 2x. 5 times 10 is 50. Get our x's on one side, we subtract 2x from each side. 10 minus 2x is 8x. Subtract 10 from each side. 50 minus 10 is 40. So 8x equals 40, divide both sides by 8, and x equals 5. Take that 5, plug it back into one of the original equations. I used the top one. Y equals 2 times 5 plus 2. 2 times 5 is 10, 10 plus 2 is 12. So y equals 12, and our point of intersection is 5, 12. And one last example of the equal values method. We have 4x plus 2y equals 6, and 3x minus 3y plus 9 equals 0. Now, this problem may actually be solved a little bit easier using another method that we're going to learn in a couple of lessons. But for the time being right now, we can still solve it using the equal values method. Problem here is they're not both equal to the same thing. So the first thing that we have to do is get them both equal to the same thing. So let's get them both equal to y. So I've written each equation separately, and we're going to solve each equation so that it's in y equals form. So for the one on the left here, we start by subtracting the 4x over, and we get 2y equals negative 4x plus 6. We just want y though, so we have to get rid of that 2. So we're going to divide by 2. We have to divide everything by 2. So 2y divided by 2 is y. Negative 4x divided by 2 is negative 2x. 6 divided by 2 is 3. And we have the equation y equals negative 2x plus 3. Over here, since I want my y to be positive, I'm just going to move that over to the other side first. So I'm going to add 3y to each side. I get 3x plus 9 equals 3y. I just want y though, so I'm going to divide by 3. everything divided by 3. 3x divided by 3 is x, 9 divided by 3 is 3, 3y divided by 3 is y. So I have the equation y equals x plus 3. Doesn't matter that it's written in reverse order. So they're both equal to y. We can set them equal to each other. Negative 2x plus 3 equals x plus 3. Get our x's in one side, so add 2x to both sides, and we're left with 3 equals 3x plus 3. Subtract 3 from both sides, and we get 0 equals 3x. Divide both sides by 3, and x equals 0. We then need to plug that into one of our equations. Either one will work. I use the top one. So if x equals 0, I have 4 times 0 plus 2y equals 6. 4 times 0 is 0. So we just have 2y equals 6. Divide both sides by 2, y equals 3. So our point of intersection is 0, 3. So the basics of the equal values method: if two equations are equal to the same thing, or if you can make them equal to the same variable, you can set the other parts, the other half of the equation, equal to each other.